This is a new chapter, chapter number 10. The chapter is on matrices, and this is the first part. Now, talking about matrices, matrix is the singular form and matrices is the plural. Many matrices together are called matrices, and matrix is the singular form, one matrix and many matrices. Okay. Now, if you consider a matrix is an arrangement of numbers or alphabets, or it can be anything which is arranged in rows and columns. Okay. Anything which is arranged in rows and columns is called a matrix. Okay. Usually, matrices are represented by a capital alphabet. So, A is the matrix which I have considered here. And matrices usually are put in square brackets. Okay. You can write all these elements in square brackets. Now, there are four elements which I have written inside this matrix. The first element is 4, second element is 2, third element is -3, and the fourth element is 5. There is no sign in between 4 and 2. Okay. There is no sign in between -3 and 5. There is no sign in between 4 and -3, and there is no sign in between 2 and 5. There are only gaps. Okay. So, 4 elements are there. These 4 elements, which are numbers, are arranged in rows and columns. Now, you should know what is a row. Row is anything which is arranged from left to right, and columns are arrangement from top to bottom. So anything which is from left to right is a row, and anything which is from top to bottom is a column. So let's see how many rows and how many columns are there for this. Okay. So if you look at this one, 4 and 2 are the elements which are there from left to right. 4 and 2. So this becomes the first row. The elements in the first row are 4 and 2, and that becomes the second row. So -3 and 5 are arranged in the second row. So this becomes the first row, this is the second row. Similarly, about columns, anything from top to bottom is considered to be a column. Okay. So columns are, look at this, 4 and -3 are the elements which are there in the first column, and these ones, 2 and 5, are present in the second column. So this way they are rows, and this way they are columns. So matrix A has 4 elements. These 4 elements are arranged in 2 rows. There are 2 rows and 2 columns. So anything that can be arranged in rows and columns is called a matrix. Another example I can give you, look at this. B is a matrix which has A, B, C, D, E, F, G, H, and I. The name of the matrix is B, and there are 1, 2, 3, 4, 5, 6, 7, 8, and 9 elements. These 9 elements are also arranged in rows and columns. Okay. So A, B, C, this one is your first row. D, E, F is in the second row. G, H, and I are in the third row. Similarly, about columns, A, D, and G are in the first column. B, E, and H are in the second column, and C, F, and I are in the third column. So here also you have rows and columns. So this arrangement of elements in rows and columns again is called a matrix. Okay. Next, you have to know about order of a matrix. That's the first thing. Order of a matrix. Order of a matrix means you have to find how many rows and how many columns it has. Order means number of rows by number of columns. Okay. Order of a matrix means you have to find how many rows it has and how many columns it has. Rows are always written first and then comes the columns. So number of rows by, this is not into, this is called by. Okay. So order is usually written as rows by columns. Okay. So I've considered a matrix A. A is a matrix which has 1, 2, 3, 4 elements. Okay. These 4 elements are arranged in how many rows, how many columns is what you are going to find. Okay. So this is your first row. Okay. And this is your second row. So how many rows are there? There are 2 of them. So order of A, order of matrix A, order of A is, first you have to write number of rows. So there are 2 rows, it has 2 rows by. Next you have to write number of columns. So you have to see how many columns this has. So let's see the columns. That is your first column, that is your second column. So it has 2 rows, that is what is here, by how many columns are there? That is 2. So it is a 2 by 2 matrix. So matrix A is a 2 by 2 matrix. It has 2 rows and 2 columns. There is one more example which I have written here. B is another matrix which has 3 elements, A, B and C. Now you have to see how many rows, how many columns this has. Let's see the number of rows. That is your first row. A is in the first row. B is in the second row. C is in the third row. So order of B, order of matrix B is number of rows by number of columns. See the number of rows, 1, 2, 3 rows. So this has 3 rows by, you also have to see how many columns it has. The number of columns, that one is a column. There are no more columns. This is the only column which is there. So it has 3 rows that I have written here by, how many columns does it have? It has 1. Okay. So 3 by 1 matrix. So the first one, 4 elements were there. First row, second row, so 2 rows. First column, second column, it has 2 columns. So it's a 2 by 2 matrix. Matrix A has order 2 by 2. And matrix B has order 3 rows were there. The red ones are the rows. Okay, 3 rows by, it has only 1 column. Okay, so it's a 3 by 1 matrix. So this is finding order of a matrix. Next, about the second type of matrix, which is called zero matrix, otherwise called a null matrix. A zero matrix, otherwise called a null matrix. I have written few examples. Example for a zero or a null matrix is all the elements in the matrix should be zeros, no other numbers. Okay. All the elements which are there should be zeros. So the first example is, this is a matrix which has first element 0, second element 0, third element 0, fourth element 0. All the elements are 0. So this is an example for a 0 or otherwise called a null matrix. This is also an example for a 0 or a null matrix, because look at all the elements. All the elements are zeros. Okay. So this is the second example for a 0 or a null matrix. In the first case, this is a 1, 2 rows, 2 columns, so it's a 2 by 2 matrix, 2 by 2 zero matrix. This is 1, 2, 3 rows, 1, 2, 3 columns. It's a 3 by 3 zero matrix. Okay. So these are examples for zero or null matrix. Then the third one that you have to know is about a unit matrix, otherwise called an identity matrix. The name given is, it is called a unit matrix, otherwise called an identity matrix. And this unit matrix or an identity matrix is always represented by a capital I. I stands for identity matrix. Now in an identity matrix, the diagonal element should be 1, the rest should be zeros. Diagonal element should be 1. Now for a matrix, the diagonal is from the top left to the bottom right. Top left to the bottom right. This is the diagonal. So look at the diagonal. The elements in the diagonal must be 1s, the rest are all zeros. Look at the second example. I again stands for identity matrix. This is your diagonal. Look at all the elements in the diagonal. They are all 1s. The rest are all zeros. Okay. So for a unit matrix or an identity matrix, diagonal elements should be 1. All the other elements should be 0. And this sort of matrix, that is unit or identity matrix, is always represented by a capital I. Okay. So that's about identity matrix. And then the fourth one is about transpose of a matrix. Transpose is changing a matrix to a certain form. Okay. I have written an example. A is a matrix whose elements are -3, 2, 4, -5. These are the elements. In the first row you have -3 and 2, and in the second row you have 4 and -5. Okay. We are going to find transpose of this matrix A. A's transpose is what you are going to find, which is normally written as A T like this, or it can be written as A small t like this, or it can also be written as A dash. All mean that transpose of matrix A. Transpose of matrix A. This is also transpose of matrix A. Now, what do you do in a transpose is you change the rows to columns. In the first row you have -3, 2. This becomes your first column here. So -3, 2 becomes the first column. So -3, 2. This has become like this. The second row becomes the second column. Second row here is 4, -5. This becomes the second column, 4, -5. This change is called transpose of a matrix. Okay. So all that you have to do to get a transpose is change the rows into columns or change the columns to rows. Okay. It means the same. And they are represented by A, on top you write T, or A, on top you write small t, or A dash. Okay. All mean transpose of a matrix. But if this was matrix B, then this will be B transpose, B transpose, B transpose. Is it clear? Then, about equal matrices. The fifth one is about equal matrices. If this is one matrix, A, B, C, D, 4 elements are there, is equal to another matrix which is X, Y, Z, W, also having 4 elements. The number of elements should be same. If this has 4 elements, this also must be having 4 elements. And you can see that this matrix and this matrix are equal. If it is so, then the first element here must be equal to the first element here, which means A and X must be equal. Therefore, A is equal to X. Similarly, second element is B here, second element here here is y. B must be equal to y. B must be equal to y. Similarly, that's the third element, that is the third element. They should be equal. So you get C is equal to Z. And similarly, fourth element here is D and the fourth element here is W. Both of them should be equal. So D must be equal to W. First element must be equal to first element here because both the matrices are equal. So first element must be equal to first element, second with second, third with third, and fourth with fourth. Okay. So A is equal to X, B is equal to Y, C is equal to Z, and D is equal to W. Okay. That's about equal matrices. Now, these are the types of matrices and what all changes you can do. Next is about operation of matrices. We are going to see how to add matrices or subtract matrices, multiply numbers with matrix, or multiply two matrices. These are the operations that you are going to see. Addition of matrices, subtraction of matrices, multiplication of a scalar quantity or number with a matrix, and multiplication of two different matrices. Okay. These are the operations that we are going to see. The first one is about addition of matrices. How to add two matrices. Imagine A is the matrix whose elements are 3, -2, 4, 0. And B is the second matrix whose elements are 4, 3, 2 and 5. Now we are going to find A plus B. A plus B. We are going to add A with B. So A plus B. First is A. So 3 -2, 4, 0. That's A. Plus. That's plus. Second matrix is B. That's 4, 3, 2, 5. And to add. If you're going to add these two matrices, this is what you're going to get. In addition, you will add the first element with the first element of the second matrix. Okay. That is 3 has to be added with 4. So you get 3 plus 4. Okay. And second element you will add with second element here. That is -2 plus 3. So -2 plus 3. And then the third element with the third element you will add. Okay. So you will get 4 plus 2. And lastly, the fourth element with fourth element here. Add these two. So you will get 0 plus 5. And simplify this. You will get 3 plus 4, which will give you 7. -2 plus 3, that is 3 minus 2, which is 1. 4 plus 2, which will give you 6. And 0 plus 5, which will give you 5. So this is the value of A plus B. A plus B is what we are going to find. So A plus B is this one. Similar to addition is the subtraction. So second one is subtraction of matrices. Is the same matrix which I have taken, same matrix. A is this, B is this. But now we are going to do B minus A. B minus A. This is matrix B minus this is matrix A. B minus this is A. Now to subtract, as I said, it's similar to addition. Take the first element here and subtract with the first element here. First element with first element. That is 4 minus 3. 4 minus 3. Okay. Next, second element with second element. That is 3 minus minus 2. 3 minus of minus 2 becomes plus 2. Okay. So 3 plus 2. And then the third element with third element, that means 2 minus 4, 2 minus 4. And fourth element with fourth element, that's 5 minus 0. 5 minus 0. And simplify this. 4 minus 3 gives you 1. 3 plus 2 gives you 5. 2 minus 4 is minus 2. And 5 minus 0 is 5. So this will be the value of B minus A. Okay. So addition and subtraction are quite simple. The next one is about scalar multiplication, which means you're going to multiply a matrix with a number. Okay. So I have considered A is a matrix whose elements are 2, 1, 0, 3. And I am going to find 4A, means 4 has to be multiplied with matrix A. Okay. So this is equal to 4 is going to be multiplied with matrix A. Matrix A is 2, 1, 0, 3. That's what I have written here. This is matrix A. 4 has to be multiplied with matrix A. This is matrix A. Okay. So all that you are going to get is multiply the scalar quantity, a number, with each element that is there inside the matrix. Multiply the 4 with each element that is there inside the matrix. So this is what you are going to get. 4 into 2, which will give you 8. 4 into 1, that's 4. 4 into 0, it gives you 0. 4 into 3, that will give you 12. This is scalar multiplication. Multiplication of any number with the matrix. Just multiply that number with all the elements which are there inside the matrix. Okay. That's scalar multiplication. This is from the exercise. Exercise 10, question number 1, subdivision 4. Question is, given that matrix A is this, matrix B is this, matrix C is this. 3 matrices are given, A, B and C. Find matrix X in each of the following cases. This is what is given. A plus X is equal to B plus C. You know A, you know B, you know C. These 3 matrices are known. You have to find what is X. X is what you are finding. Okay. So before you substitute the matrix, simplify this. Keep the X on the left side. So this is equal to B plus C was on the right side. Take this A to the other side, it becomes minus A. And then substitute the matrix. So X is equal to B is minus 2, 1. Sorry, minus 2, minus 1. C is 1 and minus 3. And minus A is 3, 2. Now to simplify this. So you get X is equal to, do everything together, that is the addition and the subtraction together. As I told you, when you add or subtract, you use each element separately. That is, first element is minus 2 plus 1 minus 3. Okay. So I've used these, that one and that one. Minus 2 plus 1 minus 3. That's what I've written here. And secondly, minus 1 plus minus 3. Plus into minus is minus 3 minus 2. Simplify this, that will give you matrix X. So matrix X is equal to minus 2 minus 3 is minus 5. Minus 5 plus 1 is minus 4. Then minus 1 minus 3 is minus 4. Minus 4 minus 2 is minus 6. This is matrix X. This is from the same exercise. Question 2a. Work out, where possible, the following sums. Find matrix A that satisfies the equation. this is the equation that is given. 2A minus this matrix is equal to this matrix. And you have to find the value of A, that one. So what I'll do is, I'll keep the 2A on one side and shift this matrix to the other side. So 2A is here is equal to, this was already there, this matrix that I have written here. And when this goes that side, this was minus. When this goes that side, it becomes plus this matrix. All that you have to do is add both of them. Okay. So you will get 2A is equal to, now simplify, minus 5 plus 3 is minus 2. 8 plus minus 2 is minus 2. 8 minus 2 is 6. Minus 2 plus 4 is 2. And 5 plus 5 is 10. This is value of 2A. But the question is to find A. So what you will do is you will take the 2 to the other side. So A is equal to, when 2 goes the other side, don't write it as divided by 2 here. Okay. When 2 goes the other side, it becomes half. Half of matrix minus 2, 6 to 10. Now this is scalar multiplication, where you multiply whatever number is there outside with every element that is there inside the matrix. So you get A is equal to half of minus 2, which is minus 1, half of 6, which is 3, half of 2, that's 1, and half of 10, that's 5. This will be matrix A. And your homework is from exercise 10, question numbers 1, subdivision 1, subdivision 2, subdivision 3, subdivision 5, and 2, subdivision B, and question 10 and question 19.